sure do love farming. I love the smell of contributing to the agricultural industry.
Pop, 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 pop. How fun it is to be green!
Squish, squish. I love being purple.
Yay! I love growing plants. Now it's time to water you guys to watch you grow.
Wow, you love vegetables so much. If you were a vegetable, you would be a cucumber.
Wow, you're really extraordinary.
Wow! What on earth is that?
Vroom, vroom, howdy y'all, I'm an intruder.
Holy guacamole!
Get out of my way, losers. I don't keep your crops.
Oh, Mamma Mia, not my crops!
Pew, pew, pew.
Oh no, my eggplants, my babies!
They got genetically modified to resist alien light rays.
I'll take that L.
What in tarnation happened?
Wow, can you hear that? It's the eggplant shriveling up and dying.
I can feel my heartbeat slowly.
Oh, y'all are so dramatic. Guess I'll have to re-eggplant. Hello class, are you ready to do some math? Here's the problem. Bob the farmer has a triangular crop field, ABC, where AC equals 20 meters, AB equals 29 meters, and C equals 90 degrees. He plants cucumbers in quadrilateral ACQP, and eggplants in triangle BPQ. One night, a mysterious UFO in the sky emits a light ray that leaves an outline of a circle. That outline is the largest circle that can fit inside the field. All the eggplants are damaged, but not the cucumbers since they are genetically modified to resist UFO light rays. As a result, Bob must replace all the soil for the eggplants to replant them. Point Q is the tangent point between the circle and side BC, and point P is the tangent point between the circle and side AB. If replacing the soil costs $12.89 per square meter, how much does it take to replace the eggplants? Round to the nearest dollar.
Okay, so first we must recognize that the outline is the end circle of the triangle, and when you connect each of the tangent points to the center of the circle, you get the in radius. And the formula for the end circle of a triangle is, and you can see how this makes sense when you connect each of the vertices to the center of the circle. So with this, you're essentially calculating the area of this small triangle, because the radius is the height, and this side length is the base of the small triangle. And with this, you're essentially calculating the area of this triangle, and with this, you're essentially calculating the area of this triangle. And from this, you could derive that radius would be. So here, we already have C and B, and to find A, we can just use the Pythagorean theorem since it is a right angle triangle. B equals to 21 meters. And to find the area of the triangle, we can just recognize that 20 meters would be the base of the triangle, and CB would be the height. So area of the triangle would be 210 meters squared. Plugging all of that into the previous formula, we would get the radius as 6. Moving on to finding PQ. So to find PQ, we would have to isolate triangle POQ, and we would need angle POQ, PO, and QO, and use sine law on them. So we've already established that PO equals to QO, which equals to 6 meters because they're the end radius. Now, to find angle POQ, we will have to isolate this quadrilateral and use the characteristic of the interior sum of the quadrilateral, which is 360 degrees. So we've already established that angle BQO equals to angle BPO, which equals to 90 degrees. This is because line AB and line BC is tangent to the circle. Now, to find B, we will have to use sine. And that should give us B equals to 43.6 degrees. And now, to find angle POQ, we would just have to subtract 360 degrees by angle BQO, angle BPO, and angle B, which should give us angle POQ equals to 136.4.
Okay, so here is a larger diagram of smaller triangle POQ, and we know that now that we know that angle O is 136.4 degrees, we can subtract it from 180 because triangle POQ is an isosceles triangle, as PO and OQ are both the radiuses of the circle and they're both 6 meters. So once we subtract that, we can divide it by 2 so we can get angle P and angle Q, and that equals to 21.8 degrees. Now using sine law, we can take, for example, angle P and divide it by the corresponding length, which is 6 meters, and then equals to this, so it's angle O over PQ. And then we can rearrange that, and that equals to PQ equals 11.14 meters.
A large image of this quadrilateral right here, and what we want to prove is that PQB is an isosceles triangle, so that we can say MB is the height since it's perpendicular. And the way we do this is by proving that these two separate triangles here are congruent. So in order to prove that MQB is congruent to MPB, we have these following 3 proofs. So we know that PMB and BMQ, this angle and this angle, are equal because they are perpendicular bisectors, and that means that since this triangle is isosceles here, we know that this angle and this angle is perpendicular, and because of opposite angle theorems, we know that this and this angle must also be right angles so that they are equal. We also know that MB is equal to MB because they have a common shared side. We also know that PM and QM are equal because they are bisectors. Since this angle here is equal and this side here is equal and this side here is equal, and they have the shared side, we know that these two sides must also be equal. So finally, we know that these two triangles here are congruent because of SAS, and that allows us to determine that PQB is isosceles, so this general triangle here, and that allows us to solve for the height. So we know that BM is now the height, and by using tangent, we know that half of 43.6 degrees is equal to 11.14 over 2, so dividing this length by 2 is equal to BM. And when we rearrange it here, we know that BM is 11.4 over 2 times tangent 21.8 degrees. So finally, we're going to find the area of triangle PQB, and that is by multiplying the base by the height divided by 2. So we know that the base is 11.4, and we know this is the height. So when we multiply it all out, we know that the final area is 77.5 centimeters square. Now we know that the rate is $12.8 over per meter square. So when we calculate the total cost, it'll be the area times the rate. And when we find the final total cost, it's $99.88 approximately, but we have to round it to the nearest dollar, so it becomes $1,000. So therefore, I'll take $1,000 to replace the soil in triangle PQB.
So provided in the word problem, it says that this circle is the largest circle that can fit in the provided field, which is a triangle. And if you don't recognize that this means it's an incircle, then this can make solving the problem really difficult and lengthen it.
The most prevalent conceptual mistake is probably not recognizing the properties of an incircle. So this whole question relies heavily on finding the end radius, and if you cannot derive the formula of AR divided by 2 plus BR divided by 2 plus CR divided by 2 equals the area of a triangle, you will not be able to find the end radius, and therefore not being able to find PQ, because to find PQ, the method that we're using relies on the end radius, or PO and QO. So another common mistake might be not recognizing tangent properties, where that the point out where the tangent and the circle intersect are perpendicular to each other, which would then prevent you from being able to know what angle OPB is or what angle OQB is. And we need to know what these two angles are in order to find what angle POQ is because of the interior angle theorem, which states that the interior angles of this quadrilateral here must equal 360 degrees. And we know that what angle B is, but without recognizing that these two angles are perpendicular, we would never be able to find angle POQ.
A property of incircles are that they're made of 3 angle bisectors of the 3 corresponding angles. And if you don't recognize that line BO is an angle bisector of B, then you can't prove the congruency of triangle BMP or BMQ. And if you don't know that these are congruent, you can't prove that PQB is an isosceles triangle, and that makes up a lot of our evidence for solving the problem.
Yay, my family's back together again!
Yay!